So we now start talking about question 5. And this is question 5. A, when is the function f of x said to be even? And when is it said to be odd? Show whether f of x is even, odd, or neither. It's question 5. A1. F of x is said to be even if f of negative x is the same as f of x. And f of x is said to be odd if f of negative x is the same as negative f of x. Then part 2, we are given a function f of x is equal to x squared over 3x minus x to the power 3. Is this function even, odd, or neither? So you say, okay, I'll bring in negative x where there is x and see what I'll get. So negative x to the power 2 over 3 by negative x minus negative x to the power 3. This is the same as x squared over negative 3x plus x to the power 3. So this is not the same as f of x. So I know not even. When you continue, you check if it's odd, you factor out a negative and see what will remain with. Will remain with 3x minus x3. Is the inside the same as f? Of course it is. So f of x is even, mean is odd. That's how you determine whether a function is even or odd. So the first thing to check is it even? Because once substitute where there is x, you take negative x, you see the output. If it's even, the outcome must be exactly the same as the question. If there is any difference, then you say it's not even. Then try to factor out the negative and see what you get inside. One thing you must take note of is that if I have 2 over negative 3, this is the same as negative 2 over 3. So it should not be a problem. So the key thing here is understanding the definition. Now these questions come. These questions are asked in the exam. As simple as they are. So you must capitalize on simple things. If hard ones are issues. You say a function is even if f of negative will be the same as the original function. If it's odd, then f of negative should be negative of the whole function. Then you have a function to check. F of negative means where there is x in the function, take negative x. You are replacing. The same way we find, if we said find f of 2, you'd have said 2 squared over 3 by 2 minus 2 to the power 3. Now not 2, but negative x. So you substitute 3 negative x minus negative x to the power 3. Then you get x squared over negative 3x plus x3. But this is not the original function, so it's not even. What if you factor out a negative from the geometry? You get 3x minus x3. But this is the negative of the whole function. Since the negative can be anyone, then you say it's odd. Understand the definition. There are questions that will come in application. Say if this function is even, find a variable, find a constant mixed. So you must be awake. B, the series expansion of 1 plus ax to the power n in ascending powers of x has coefficients 3 and 5 in x and x squared terms respectively. So there was an x squared missing. So this expansion has 3 as a coefficient of x and 5 as a coefficient of x squared. Find the values of a and n. So we know that in this expansion, you can actually expand it. 1 plus n ax plus n minus 1 over 2 ax squared plus n minus 1 minus 2 over 3 factorial ax 3 plus n minus 1 minus 2 minus 3 over 4 factorial ax4. Like that. Now we are given that the coefficient of x, its coefficient na is equal to 3. Coefficient of x squared, its coefficient n minus 1 over 2 a squared is equal to 5. And find a and b. So we have 2 unknowns and 2 equations. So you can find the unknowns. So we'll solve for a from here to give us 3 over n and bring it here. As we expand, n times n is n squared. N times 1 we get n over 2 multiplied by a, that is 3 over n squared is equal to 5. So we have n squared minus n over 2. 3 squared is 9 over n squared. This is equal to 5. So if we expand, we have 9n squared over 2n squared minus 9n over 2n squared is equal to 5. So we get 9 over 2 minus 9 over 2n is equal to 5. So if we take 9 over 2n, 9 over 2 to the other side, we get negative 9 over 2n is equal to 5 minus 9 over 2. So we have negative 9 over 2n is equal to 2 down, 10 minus 9, which is 1 over 2. So we get negative 9 over 2n to be 1 over 2. Cross multiply, we have negative 18 is equal to 2n, divide by 2, divide by 2, n is equal to negative 9. And if n is negative 9, then a is equal to 3 over negative 9, which is equal to 1 over negative 3. You can also write it as negative 1 over 3. So I have found the values of a and n. So we are saying a negative 1 over 3, n is negative 9. So our expansion now will be 1 minus 1 over 3x to the power negative 9. So that if you get wrong a and n, you can't even go to the second part, because they all depend on n. Find the coefficient of the third and fourth terms in the expansion of the above series. So
Wait,
the third,
sir, I didn't get how you got 3 over n.
since we are given that n multiplied by a is equal to 3, if we divide by n and divide by n, on the left will remain with only a, and then we'll have 3 over n on the right. Is it okay?
Yes, sir.
Sir,
Hello.
got a question down there where there's negative 9 over 2n is equal to half. How did you manage to get negative 18 over 2? There, I'm confused there.
Cross multiply here. Cross multiply. Negative 9 times 2, negative 18. 2n times 1, 2n. Then you're looking for n.
Oh, sorry, I've got it.
Okay. Yes.
Sir,
Yes, sir. What was the question?
The question was the series expansion of 1 plus ax to the power n in ascending powers of x has coefficients 3 and 5 in x and x squared terms respectively. Find a and n.
So now, sir, from that question, then what made you choose that part of the formula to work out?
So you are told that in the expansion, so you need the expansion. When you have the expansion, the coefficient of x, you equate it to the given coefficient 3. The coefficient of x squared, you get the given coefficient 5. So if the question is talking about the expansion, you must have the expansion for it to be on the same page with the question. And then go for the terms mentioned. Then have simultaneous equations. Another question? No question. Find the coefficient of the third and fourth terms. Now we already have this expansion deliberately. I went as far as the third and the fourth term. If we evaluate on the left, you have n minus 1 on the third term, n minus 2, and then a power 3 over 3 factorial is 3 times 2. The fourth term, so this is the third term. The fourth term is n minus 1, n minus 2, n minus 3 over 4 times 3 times 2 by a to the power 4. This is the fourth term. And the question says, find the coefficient of these terms. So we're just interested in the coefficients. That's why I'm not putting the x. So now, to answer part 2, we have that n is -9 and a is -1/3. So for the third term coefficient, we're saying n minus 1, n minus 2 over 3 by 2 by a to the power 3. N is -9, -9 minus 1, -9 minus 2 over 3 by 2. I can leave it like that. And then a, -1/3 to the power 3. This is -9, -10, -11 over 3 by 2 by -1/9 by 3. Because we know that 3 to the power 3 is the same as 3 to the power 2 by 3. So that this 9 and its negative can go with this 9 and its negative. This 2 can reduce 10 to 5. So that we can have +55 over 3 times 3 down, that is 9. Then the fourth term coefficient, we have n minus 1, n minus 2, n minus 3 over 4 by 3 by 2, a power 4, -9, 9 minus 1, -9 minus 2, -9 minus 3 over 4 times 3 times 2, -1 over 3 to the power 4. This is -9, -10, -11, -12 over 4 times 3 times 2 by 1/9 by 9. So that this 9 and this 9 can go. This 12 and this 12 can go. This negative and this negative can go. This 2 can reduce 10 to 5. And then we get 55 over 9. And so we have found the third and the fourth coefficient. So it's just about knowing the formula.
Sir, but why are the answers the same?
Coincidence. And we can't argue with numbers. So we respect them. The third question, state the set of values of x for which the series is valid. Now we know that the series that we have is the expansion of this x to the power -9. The range of validity, the range of validity is always the modulus of the b part less than 1. But anything that comes out of the modulus will come out as a positive number. The negative does not survive there. This means that if you cross multiply by 3, you get the modulus of x to be less than 3. And so this is the range of validity.
You are done, sir.
This one is the simplest. Done.
Can you repeat, sir?
So every time I'm given an expansion, some power, the range of validity will always be this guy less than 1. Take out a, divide by a, and you get this less than 1 over a. Now when a is known, a will come out, it was negative, but the modulus is meant to make any negative number positive. So negative 1 over 3 has become positive 1 over 3. Modulus of x less than 1. Cross multiply, you get the modulus of x is less than 3. That's all.
So, sir, in this matter, the n in terms of -9 is not considered, right? On the one.
No, you're interested in the inner parts. You don't care about the power. Simplify and express 2 over 3 minus 3 root 27 plus root 108 in the form a plus b root 3. This number here is very, very important. It tells us what to do to the numbers that are inside the root. So we got 27 and divided by 3. We get 9. We got 108 divided by 3. We get 36. Then we come back here. From surds, the root of a by b is the same as root a root b. So we have 3 minus 3. 27 can be written as 3 times 9 plus 108 can be written as 3 times 36. And then we split. We have 3 minus 3 root 9 root 3 plus root 36 root 3. This is 3 minus root 9 is 3. 3 times 3 is 9. Root 36 is 6 root 3. So we get 2 over 3. Negative 9 plus 6, we get negative 3 root 3. At this point, we rationalize by multiplying this by the positive 1. Rationalize, you multiply by the positive 1. So that you can get 2 times 3, 6. 2 times 3, 6. Over 3 times 3, 9. Minus 3 times 3, 9 root 3, mean plus, and then minus 3 times 3, 9 root 3. Then negative 3 root 3 times 3 root 3. Negative 3 times 3, we get negative 9. Root 3, root 3. Root 3 times root 3, we get 3. This will give us negative 27. So we have negative 27, but this is the same as 6 plus 6 root 3 over 9 minus 27. This is 6 over 9 minus 27, we get negative 18. Plus 6 over negative 18, 3, which is negative 1 over 3 minus 3 over 3. This is the form a plus b root 3, where a and b are rational numbers. So they're very, very simple.
So I asked a question on binomial, but I was locked out due to the poor connection. Where there was negative 9 on top.
Hey, what is it here?
Yeah, no, I was locked out. This is when I'm logged in.
So I say that negative 9 has no use in the validity.
All right, thank you.
D, if alpha and beta are the roots of negative x squared plus 2x plus 3 is equal to 0. Find the equation whose roots are 1 over alpha and 1 over beta. Now we know that if you are told there are some roots, if you add them, you must get negative b over c over a. If you multiply them, you must get c over a. So that if we add the two roots, alpha and beta, we'll get negative 2 over negative 1, which is 2. If we multiply them, we'll get 3 over negative 1, which is negative 3. So we have alpha plus beta 2. We also have alpha beta negative 3. This is what we have. We must find the equation whose roots are 1 over beta and 1 over alpha. So you can always write like this, so that you get x squared minus alpha beta as the common denominator, and then we'll have beta plus alpha plus 1 over alpha beta. Now we know alpha plus beta is 2 over alpha beta negative 3. Alpha beta negative 3. So we get x squared plus 2 over 3x minus 1 over 3 is 0. So you get 3x squared. If you multiply throughout by 3, you're going to have this guy here as the equation, whose roots are alpha, are 1 over alpha and 1 over beta. As simple as it is. So 2 more questions, the completion of this paper.
Wait, sir. How was it 3x squared plus 2x?
So multiply throughout by 3. Are you seeing that? 3 times x squared, we'll get 3x squared. Plus 2 over 3 times 3x minus 1 over 3 times 3 is 0 times 3. So we'll have 3x squared. These 3's will cancel. We'll get 2. These will cancel. We'll get 1. On the right, we get 0.
By 3 from where?
On the denominator,
Oh.
So my question is on the equation, like your substitution of 2x. Why was 2x equated to them? Those things in the bracket.
why was 2x equated to?
To 1 over alpha plus 1 over beta.
We didn't equate 2x here. We just said that alpha plus beta is 2. So where there was alpha plus beta here, we substituted 2. Where there was alpha beta, since alpha beta is -3, substitute -3. So where there is alpha beta, we substitute -3. We did not do any equating. I don't know if your eyes can see now.
Yes, sir.
Okay. So let's log out and quickly log back. We'll do question 6.